So we are working on part 2 of the physical and chemical weathering lab. It looks like this, our first page. It's got the image on it. So find that page and read along. So chalk, just like regular old chalk for the chalkboard, is a type of limestone, and this is limestone here, it's a type of limestone, made of the shells of tiny organisms. When you write your name on the chalkboard or draw a picture on the driveway with a piece of chalk, you are leaving behind dead organisms, really millions of dead organisms. By scraping the chalk against the ground, you are mechanically or physically weathering the chalk, right? So if I rub this against something, I am breaking the chalk, which is a form of weathering, right? So weathering is breaking rocks. In this experiment, this experiment will help you understand how chalk can be chemically weathered. So, if you were to look under an electron microscope, take a picture with an electron microscope of chalk, this is what you would see. So, a bunch of tiny shelled organisms, ancient organisms, all right? So, I also want to point out that the mineral that makes up chalk is called calcium carbonate. And this is a crystal of calcium carbonate, or a crystal of what we call calcite. Calcite is the crystal or the mineral that makes up limestones. And in this case, this limestone, if you look, has fossils in it. Just like how this is made of fossils, this rock here is also made of different fossils. These are shelled organisms, and these are like microscopic organisms. So what I want you to do now is you'll see on the lab, there is a hypothesis section. So we're going to write a hypothesis, something that can be proven wrong, but that we think is going to be correct. So what happens to the chalk when we put it in acid? So make a prediction about what you think will happen to the chalk when we put it in acid. Also, make a prediction about how the surface area or the amount of area that the chalk can cover may affect the rate of weathering. So if I were to turn this chalk into a different form to make it spreadable, I would just crush it into pieces so I could spread it out over a larger surface. So that question is really asking you, what do you think is going to make the chalk weather more? If it is just one solid piece, or if we break those pieces into a large surface and then weather that large surface. And the final prediction is, how do you think heat affects the rate of chemical weathering? Do you think chemical weathering or chemical reactions happen more often in cold environments or in warm environments? So make those predictions. You can pause the video to make those predictions and then turn it back on for the actual lab. Okay, so we're going to do test number 1. So test number 1 is this initial box. The next tests are on the next page, right? So this next test and then this next test. But we'll focus on the vinegar and water part of the lab. So I'm just going to fill that with a little bit of water. Water is going to be on the right side, and vinegar, or the acid, is going to be on the left. Now vinegar is acid, but it's not necessarily like the acid that you would imagine or see in like a movie. Now, if you left vinegar on your shirt, and like you got it on your shirt and you left it there for like a week without washing it, you may notice a color change. You may even notice on a certain material that it would burn through, but it's not like getting this on your hands is going to really cause any issue. Now, with that said, as this being a science experiment, you're definitely going to want to have access to water just in case you do get it on your skin, right? If you were doing this with a stronger acid or a more volatile acid, you'd want to wear protective eyewear. Anyway, so I'm going to take my 2 pieces of chalk or 2 pieces of limestone, and I'm going to drop them into the water and the vinegar. What I want you to do is to make a drawing of what you see happening in the water on the right and the vinegar on the left, and then write a description of what you see happening. So then you remember when you look back at this, what it looked like, and you can write down, and you can refer to what you wrote down about what you saw. So I'm going to drop them in, and I will bring the camera over. So I'll put them together. So what you're going to want to do is write down the basic difference between what you see. So on the left, we have the vinegar. You're going to want to draw what you see. And on the right, you're going to have the water. And you're going to want to draw what you see as well. So right off the bat, we can see that there's a lot more bubbles forming on the vinegar. And those bubbles are rising. And it looks like the chalk is almost slowly being torn apart. While the water definitely has some bubbles on it, but those bubbles really aren't changing much. Or if they are, it's happening very, very slowly. So make sure you draw what you see happening and give a description of what you see happening in both the water on the right and the vinegar on the left. All right, so we can pause this. You can pause this, you can make your drawing and description. I'm going to set up the next experiment. All right, so experiment number 2 is going to be having crushed chalk put into acidic vinegar and then whole chalk put into acidic vinegar. All right, so what are we actually doing by crushing the chalk? Like I said before, when we crush chalk, we're able to spread the chalk over a greater area, right? So like a whole piece of chalk, not broken, can't be spread out. It has a specific surface area, or an area, the round part here, the end here, and the end here. That makes up a certain amount of area that that makes up a certain amount of area exposed at its surface, right? So the only way that I could increase the surface area is by crushing this chalk. So in this case, I'm going to take 2 similar sized pieces of chalk. One of them I'm going to keep whole. The other one I'm going to crush into pieces. Now, which one am I able to spread across more of a surface? This one. So by crushing something or breaking something, we're opening up the inside to be exposed at the surface. Now, I'm going to drop this piece of chalk in here, and I'm going to sweep this chalk into here. Did I say chocolate? I hope I didn't say chocolate. And we're going to observe. Now, you're going to want to draw what you see happening and describe it. So this is the whole piece of chalk on the right. This is the powdered or the crushed chalk with the increased surface area. So the crushed chalk, or the chalk with the more surface area, seems to have a lot more reaction, a lot more chemical reaction happening on the inside. The chalk in the vinegar we saw last time is very similar. It's bubbling, it's starting to flake a little bit, but this is super reactive. And you could probably also hear it. So let me see if you can hear it. Maybe, maybe not. All right, so make sure you have a drawing of what you see happening here, and let me give this a little shake. Agitate it a little bit. Almost looks like convection cycles. All right, so we have one more experiment to set up, and that is with hot and cold vinegar. So let me heat up some vinegar real quick while I get it set up. So I've got cold vinegar and I've got hot vinegar, all right? Now I want to preface this by saying that in Florida, their rocks underneath their houses, underneath their roads, are made up of limestone. And limestone is this rock that we're seeing which it bubbles with acid, okay? So imagine having your house built on this, right? So we have a house here, like a little mini house built on this limestone, and we had acid running underneath through this rock, right? So it's running through this rock. It's going to dissolve this rock and form a little cave in this rock. Eventually, maybe that house you built, the rocks underneath it are so thin because that cave continues to wear out a bigger and bigger hole that your house falls to the ground. This happens. This is called a sinkhole. It's real. So if you're going to buy a house on limestone, now there's not necessarily going to be a good chance that your house is going to fall into the ground, but maybe you should have someone like a geologist or someone who studies the earth, have them come in and test to see or to try and figure out if the rocks underneath are stable. Now, we need to figure out if there's going to be more chemical weathering in hot temperatures or more chemical weathering in cold temperatures. So the left beaker is going to be my hot vinegar. There it is. And my right beaker is going to be my cold vinegar. So, hot vinegar, cold vinegar. Be ready. Cold vinegar and warm vinegar. So be ready to draw these out. So I'm going to drop these in, and I'll bring you closer. So the warm vinegar is on the left, and the cold vinegar is on the right. So we need to think about how the temperature on the Earth varies, right? So the equator is warmer than the poles, like the North and South Pole. So if we have acid rain falling down, which a lot of the rain on Earth is acid rain, if we have acid rain falling down in a cold climate like this, even if we have limestone rocks, so on the right, even if we have